So thank you for spending a little bit of your Friday afternoon with Veracity Industrial Networks today. My name is Jason Weber. My position at Veracity is Vice President of Product. So all things product related, product marketing, that sort of thing rolls up to me. And so what I'm going to do today is introduce you to our platform and an exciting new product that we have. I know that some of you are simply here or drawn here because of the new product. Let me just quickly introduce this. So we are we've got early versions here, but we will be soon releasing a OT network security appliance. And what this is a combination of our OT network controller. And if you don't know what that is, I will get to that momentarily, combined with a 7-port switch. I have one of the pre-production models here, not sure because I can't see myself on the screen if you can see it, but there are 7 ports on the front, and I have all the details in a later slide about those because a lot of people want technical details. But this is really geared towards remote assets, small energy locations, substations, things like that, windmills, grain elevators, cement plants, smaller networks that really need a simple solution. And right now we have combined our SDN OT Network Controller with a 7-port switch just to make sort of a plug and play type of solution for you for some of these environments. But now that if that's all you came for, thank you for coming. But I'm going to go through a little bit about what the OT Network Controller is, why SDN is important, how it works to sort of build up the value, and then I'll compare and contrast what the current controller, which is a software solution, versus this network appliance, where we sort of see these fitting within the market. Some of the early people that we've shown this to have been really excited, especially around remote assets and small locations. That's really where people are interested in this type of a solution. It's just simple. So we're going to back up a little bit and get into this. Year 2000, what was big in the year 2000? Ford Taurus was like every single rental car you could get. Flip phones were out. Those were big. A Pentium 3 with a whopping 128 mega RAM and 20 gig hard drive. That was a great desktop computer back then. The iPod was just really in its heyday then. And guess what? Plant floor Ethernet was introduced back then. Profinet, Ethernet IP, Modbus TCP all came out within a few years of each other. Fast forward to today, what's still around? Profinet, Ethernet IP, Modbus TCP. That's still state-of-the-art networking technology. So we're dealing with 20-plus-year-old technology here. The network 20 years ago was a little different than it is today. Back then, air gaps were really common. No integration between IT and OT, really. You might have had a distribution switch or some type of small switch, and then just a few of the larger, more capable assets on the network. HMIs, computers, maybe drives, PLCs, those sort of things. But you fast forward to today again, way more complex. And there's no way I could possibly represent the complexity of today's networks on this screen and actually have it be at all readable. But you've got multiple management tools. You've got different switches from different vendors. You've got every device that's been created now has Ethernet capability of some type. In order to manage this, you've got multiple VLANs. You've got access control lists if you're brave enough to use them. Like I said, multiple management tools. And it's really makes for a fragile network. If you've ever had a loopback in your network, that's because of these sort of things. If you've ever accidentally unplugged something from a switch and you plugged it in what you thought was the same port, and now you're on a different VLAN and it quits communicating, all these things are very problematic because this fabric of this network is brittle. It is fragile, and because of that brittleness and fragility, it's a lot easier for cyber criminals and bad actors of any type to get in there and access things. Because if you ever ask a customer what their network looks like, do you have a network drawing? Do you know what it is? They usually look at their shoes. And you might have a network drawing that's, even if it's 2 years old, it's completely out of date because things happen. Production goes down and everything stops in order to make that happen, including rules around network management. And so what we're proposing is a better way, a simpler way. You have all of the same devices that you had on your network before. Everything's still connected, everything is still talking, but instead of having all of these legacy tools to manage everything, manage it from a single location. Remove a lot of those frustrations. Know what's talking on your network. So that is what the Veracity OT Network Controller does. We've taken software-defined networking and we've applied it to the plant floor. So we introduced this product now about 5 years ago, 4.5 years ago, and it centrally manages your traffic. It manages it from all in one location, and we do this using software-defined networking. Software-defined networking is the tool that enables the cloud and server farms and things like that to even exist. The networks on those, the way they're managed, would be impossible to manage with traditional networking tools. And so over a decade ago, software-defined networking, well, it was way more than that, but over a decade ago, it was applied to the cloud space. And when applied there, it allows them to very easily manage all of the traffic and flow of data on their network. And so, but nobody had actually applied it to the OT space before. And so what we've done is we've created a OT specific SDN controller. And we use rules on communications from device to device or zone to zone to manage communications, not only to which device, but also by what protocol. And so what this gives you is much simplified network administration, line startup, a micro-segmented network, and I'll get into how that works in a little bit. It lowers your operating costs. You can buy less expensive switches. You don't need, multi-thousand-dollar managed switches to do this. Every device that's communicating through an SDN switch is visible on our network, and it makes a very robust network that has many fewer disruptions from failures. Like I said, those VLANs, those loopbacks. We were talking a few months ago to a food manufacturer, and they had 24 plants, I think, and 3 people that were in their network and security team for all that infrastructure. And they had a loopback that happened in their plant that took an entire plant down for 5 hours. Think of how much waste and how much cost that was that could have been avoided if they were on an SDN network. So how does this all work? So we have a network here. It's a mesh network, which is a little unusual, but completely acceptable and usable within a SDN world. But by default, no traffic is allowed to communicate on this network. Nothing gets past the port of the switch besides ARP traffic on this network. And that's just the heartbeat of the network. It's required. But if I want the PLC in the lower left to talk to the SCADA box on the upper right, I need to now create a rule. So I put a rule in the controller, and the controller does the rest. It talks to the switches. It sets out what are called flows in those switches to make sure that the data can pass from one location to another. If for some reason that connection breaks, we reroute it. We know that it's no longer communicating or able to get through, and the switches and the controller communicate with each other, and we lay out new flows. It may not be as quite of a short of a path like in this example, but it's perfectly acceptable. And then because we manage devices by the endpoint, not by switches and not by ports, if you happen to move a device either from one port to another on a switch or even one switch to another, it's fine. It finds that endpoint and it reflows it, and now you're communicating again. So gone are the days of plugging into the wrong VLAN and everything shuts down. You just plug it into any port on that switch and you're good to go. And so this is the high level, the sort of 100,000 foot level. Let's go down one level and I'll show you a little bit about the mechanics of how this works. And this is a very simplified view of it. There's networks are very complex, but I think it'll get the point across. So if you have traffic on your network that is allowed, as in there's a rule in the controller that says this is okay. So this PLC and this HMI want to talk to each other via Ethernet IP. And you notice I mentioned the protocol because Ethernet IP may be okay, but FTP isn't, that sort of a thing. But the first time the switch sees that Ethernet IP traffic, it queries the controller. What do I do with this? And the controller says, I have a rule for it. It's okay, pass it. It lays a flow in and it passes that packet. Then, because this question comes up, do we ask every single packet? No, we don't. If the switch now remembers. So If you lose connection with that controller, the switch now just doesn't need to ask next time it sees the packet. And every time it sees the packet from then until a rule changes or something, the switch just says, okay, I will pass that. And that allows for, the Ethernet level speeds that we're talking about are used to, because we don't request it every single time. This also gives you a level of resiliency in your network, because the controller is not required on the system for the network to function. The network will continue to function without the controller. And then you bring back the controller. But I mean, the most important thing to us is for the network to continue to run and produce, allow people to produce whatever product they're producing, whether it's energy or, snack bars, anything in between. If you have a bad actor or somebody just trying to get in, which we'll just call them a bad actor, because it might be an OEM for a machine. It might be some engineer that's not supposed to be making changes that does it anyway. But if you have a bad actor in there, you have a new device or an existing device talking in a new protocol, and there's no rule for it, the switch will query the controller just like it did with allowed traffic. But the controller say, I don't have a rule for this. And so that communication stops at the port. This is how we microsegment the network. They're not allowed access to other things in the VLAN. They are not allowed access to anything except for what is on that, what it's specifically allowed by the controller. So this blocks it at the port. It also logs this. It gets there's an entry put into our event log, as well as made available to other products if you so choose through a northbound API. So audits are created for this. So let's back up to our two form factors that we have. We've got the OT Network Controller, which is a piece of software. It typically runs on the virtualization stack. Some companies will run on a bare metal computer. It can manage any OpenFlow capable switch, and it's really appropriate for any size installation if you want to. And high-speed applications are also fall into this. It's not that it can't do slow-speed ones, obviously, but I'm going to recommend it for high-speed applications because our security appliance is a much smaller system. It's got the OT Network Controller software package and a 7-port switch integrated into one thing. When you receive this package, they are pre-set up, so they're communicating with each other, and the switch has been adopted by the controller. It also can manage any OpenFlow capable switch. You don't lose that. You can make larger networks than just this box, but it's really targeted at remote assets. So, small energy locations, windmills, grain, cement, proof of concept testing. People will want to use this in their labs to play with it. It's a nice, easy box to have for that. If you've got a problematic network segment in your network and you want to try this out and try to fix it, something that keeps you up at night, this is a great solution for that. Everybody asks about this. Essentially, what are the specs of the box? And it is got 5 just regular RJ45 ports. It's got 2 of the SFP ports. It has a dual power supply capability. I'm running mine on my desk next to me at 24 volts, but 20 to 54. It's got a pretty wide operating temperature range of -40 to 70, and pretty wide relative humidity range, non-condensing. Some decent certs on it, and then it is a DIN rail or wall mount box. I will hold it up one more time so you can see for reference. Like I said, can't see myself, so give you an idea of the size of it and the ports, but certainly be happy to provide any information that people want afterwards. So sort of the 2 ways they get deployed. First, if you have a large network, we've talked a lot about SDN, but because of the nature of the industry that we're in and OT networks, there's no such thing as a homogeneous network. And we know that there's just not a lot of greenfield opportunities here. So we can seamlessly integrate with a legacy network. So if you've got unmanaged switches or managed switches in the network, that's fine. You lose the abilities that SDN has, but we will definitely work with that. If you have an existing VLAN infrastructure, we'll pass that information through. If you have any devices that are talking to, there's always going to be unmanaged switches and panels and things like that. Your network will continue to run. But what we've done is an easy way to segment your network. At the distribution level, you'll quite frequently see a Cisco 9300 Catalyst. It's the most common switch we see out on plant floors as far as rack mounted ones. And you can actually just activate it into OpenFlow mode. You put a controller in your virtualization stack, talk to that, and you have automatically segmented your network very, very easily. Everything that passes through this is under the same types of controls that I showed in the previous slides. Now, if your switches aren't all SDN capable, because not every single one is going to be, if you have a part of the network that is critical or a part that's problematic, you can either put an SDN switch on there, activate to it, and everything that's talking through that switch, you've got full visibility and control. When we work with legacy networks or traditional networks, you'll see that if there's east-west traffic that's not going through an SDN switch, we have very little visibility and control over that. But if you have east-west traffic that actually goes up through here, so one segment to another, we can actually provide some control and visibility to the devices that are communicating on that. So there's options. What we've seen with customers is they'll apply this to a small section of their network or something like that, see the value of it, and then start working their way through the rest of the plant. Transition over is super easy because of the way we present it and the fact that we, and I'll get into that in another slide or two, but we've got some tools that allow you to very easily take a pre-existing network and get it into the SDN world. Now,
hey,
if you want to, yes, Carly.
Just to interrupt you real quick, we do have a question.
Sure.
So do you want me to read it or do you want to open your chat? Either one's
just
fine.
Just read it, it's faster.
Okay. All right. Given that an end user has the Veracity controller on premise and is using the security appliance at a machine builder's facility during factory acceptance testing, can the Veracity Enterprise instance import the configuration of the security appliance so that it can be removed during site acceptance testing?
Oh, well, that's a really good question. Not today, but there are some very easy tools that are already in the controller that I'll get to in about 2 slides that make it, for a small machine or something like that, that make it actually pretty easy to not have to worry about that. And I'll get into that in just a minute, how that works. So a direct import, not today, but there are some easy tools. So if you have the appliance, this is typically meant for smaller networks. So you'll see I've simplified the drawing here. It still works with unmanaged switches with the same constraints as the full OT network controller. You can still put other SDN switches on there, and we will have a version of our box that is just a switch and not the controller. So if you want to go that route, you certainly can, but it is optimized for simple installation. It's great for remote assets, small networks, problematic sections. So to finish out the question that was asked a minute ago, we have a tool within the controller called learning mode. And what this is you can look at existing traffic on a network, and it puts the switches into an unsecured state temporarily. And what this does is it allows all traffic to flow through the network, and we automatically generate rules. So if you have a machine that you're adding that was using the appliance that now you're putting into the full network, what you can do today is you can put that individual SDN switch into learning mode on that machine, and all the traffic that passes through that switch will generate a rule for, and then you put it back into operational mode, and you essentially have taken all of that configuration and just built it up automatically within the controller. The one thing we do recommend when using learning mode with an existing network is once you're done with that, go audit what you see. There is always junk traffic on every single network. Whether it be multicast stuff that's polluting it, or DLR beacons that are, running rampant throughout the network, or we've seen devices in IT that are trying to ping down to the OT network for some reason that we just want to block. You can block all that traffic. So apart from securing your network, this also tends to free up bandwidth on your network. So if you have this traffic, I mean, DLR rings and multicast are two real culprits when it comes to this. You can set your multicast so that it only gets to the endpoints that it really needs to get to. So you're multicasting out and there's 4 places it needs to go. You can block it from every single other place that's out there. And so this really can clean up your networking. VLANs were originally created to segment network traffic. They were not originally created as a security measure, which is one of the ways they're used now. But originally they were done to do that. We take care of all that. So you don't have to have these VLANs to protect, traffic from polluting one network or another. We do that automatically as part of this. Then once you're done with learning mode, we have something called system generated drop rules, which what we'll do is every time it sees new traffic, it will just write a drop rule to the switch and it'll log it, audit it, but the switch then won't be querying the controller very often when it sees packets that it's seen in the past. So highly recommend that gets put into place. Couple of the security standards. So I'm going to pivot from how it works and how it networks your network and makes your life easier to a little bit about cybersecurity now. There's 2 main standards that we see here in the United States and other parts of the world, 62443 from ISA and NERC CIP. NERC CIP is really a US-based energy set of rules. And there's some new ones coming out of Europe soon that we're watching as well. But essentially, we as a vendor cannot say that we're compliant with these, but we help our customers become compliant with these rules. And so our microsegmentation on 62443, if you see zones and conduits, on NERC CIP, it's the electronic safety perimeter. We exceed both of those standards with our microsegmentation solution. Network visibility that we provide by everything that talks through an SDN is visible, allows for all of the change control and also change tracking. All modifications are in the network are logged for us, and that helps us with all of the change tracking and auditing that is required within those 2 security standards. In fact, we've got some export utilities built into the software that make it a lot easier to put into some of the software tools that companies have created to help manage these audit regulations in these tools. So how do we stop these attacks? And we'll just talk about how microsegmentation helps with this. But most common attacks that are out there, and this is certainly not an exhaustive list of all the attack vectors, but phishing attacks. Everybody has gotten phishing emails. Try to get password access to one system inside of the network. And then from there, land and expand. Take an attack and go from the north, business system down to the south in the OT network. Thumb drives. This is really not like what happened with in Iran with the nuclear centrifuges, and they dropped a bunch of thumb drives in the parking lot that got picked up. No, this is, I've got an infected laptop and I'm moving a file from it to the SCADA system, and a virus just happens to come along for the ride. Misconfigured firewalls. This is so common. You throw an any rule in there. Production goes down. I can't figure out why the network's not working. Let's lower the amount of rules within the firewall to make it happen if that's where we are. And that's really problematic. Static public ports. If somebody, actually probably the biggest group that is guilty of this are OEMs. They have a machine, they want access to it so they can do maintenance. They throw a cellular modem on there and now there's access. And but there's a lot of places like that where that happens. And so that's really problematic. So proper rule creation within our software stops attacks from spreading. And that's an important thing to remember. You can make your network completely open within our software, but if you lock it down, an infected computer in finance on the left there can't even see the OT network. But when it tries to see the OT network, that gets logged. It's put in our audit logs, and then we have an API that if you have software or an SOC or something like that that needs access to that information, it's accessible. If you have on the right side a SCADA system that gets infected, it might be able to talk to the PLC because that's allowed, but it won't be able to talk to other machines in the network. if the rules are set up properly. But its attempts to do that conversation will get logged, and then it can be reported northbound through the API. So let us swap over. How am I doing time-wise, Carly? I got 15 minutes to the software, and just bear with me one moment. Come on. There it is. So here's the software. This is a simulated network. I'm gonna start up by saying that. It's a ring. These are simulated switches, simulated devices. So I have got ping traffic that is occurring throughout here in order to generate some. And I actually was not generating as much during the talk because I wasn't switching back and forth. But I can see all the devices that are attempting to talk on this network. I have a dashboard that shows me, what sort of bandwidth is being used. Let's see if I can kick that up while we're talking. I have the ability to look at what devices are communicating on what protocols. I can see which rules are using the most bandwidth. I can see what the most recent events are in the history. A lot of these are port changes because I booted it up about 40 minutes ago. Even if there's more traffic, I can even see which switches have the most traffic going through them. So there's a lot of information. This topology page gives you a lot of information. If I want to see, how these two devices are connected right now, ICMP is allowed between them, and it is actually seeing 980 bytes recently of the data. If I want to look at this switch, I can see information of, okay, what peers are there? Oh, there's 10 and 30. I can see that. I know what port they're plugged into. This is, like I said, a simulated one. Otherwise, you'd see what the line speed is. I can see what devices are connected to this switch and what port. So this is your up-to-date network drawing. Everything talking through an SDN switch, everything plugged into an SDN switch is visible in this drawing. And so you have so much power and information at your fingertips here of things you can do. I'm only going to touch on this, but I'm going to put a little plug in. We've got a YouTube channel. Just go look at Veracity Industrial Networks, and we've got a set of quick tips. And those quick tips go through a lot more detail than I'm going to today on the various pieces of this software and various things. If you do nothing else, watch the first two videos. It's like 12 minutes total of your time. Completely worth it, because we could set up much better demos on those than it is easy to do in a thing like this. Setting up rules is very easy. If I want, okay, this is a beverage line. So we've got a depalletizer HMI, and we've got a depalletizer PLC that we want to speak. I don't know, let's just grab, there's Modbus between the two of them. And I want to allow it. Oh, I also could monitor. So that's like an allow, but it also logs whenever it sees anything. So for occasional traffic, you want to know when it occurs. Block simply stops it at the port and does not log it because you're explicitly blocking it. Alert blocks it at the port, but also logs it. There's various policies I can drop this into. If I want those two to talk to each other, I'm going to leave it in the default policy right now. And for advanced users, you can actually type it in, which is kind of nice. So I hit save, and then I go to review changes, and I apply it. And now I have the ability for the depalletizer section to communicate via Modbus. I can create zones. In this zone, in this example, I've got a wet zone and a packaging zone. If you've ever been to a beverage line, there's a very wet zone, and there's also where they, wrap everything up and put it together. Then I can go look at the devices, and I can see that the depalletizer, the capper, the packer are all in the packaging zone, and the filler and the pasteurizer. I know there's other devices out there, but as I said, as an example, is in the wet zone. So we can create rules that allow entire zones to communicate if you want to do it that way. I can look at the switches. In this case, they're all open V switches within my simulator. I can see the individual ports. Oops, I need to actually select a switch first. The individual ports here on the switch and see what's connected to it, how it's communicating, all those sort of things. I can look at all the individual devices with certain protocols like SIP, which is what Ethernet IP is, we will actually go out and get more information and give you more details about the individual device. So if you've got a PLC attached to your network that's like an Allen Bradley PLC, it'll fill out more information around serial number and that type of stuff. I can lump rules into policies. And in this case, I have a couple of them. I've got one for contractors and I've got one for remote access. So if I want to give people remote access to the system, I can throw them into that. Right now it's inactive, so nobody in there is actually allowed to do anything. And then I can schedule those. So if I want to schedule a contractor to have access for a week, and this one's actually passed, but I can actually do that. So if you've got somebody you want to give access to your system for a week or two, you put them in this policy, you can actually activate it. If I want to allow remote access from midnight till 5 a.m. only, so that I don't impact my network by having other things in there, I can create schedules around that. And then there's two other things. Change sets I'm just going to talk about. Essentially, we have the ability for an approval process for rules that are created. And so if you want to create a rule and then you want to ensure that the person that creates it doesn't also approve it, you can have somebody else be an approver for that rule. And then finally, we've got a Purdue-like model. And what this does is it allows you to set up what you see as sort of the level 1, 2, 3, 4, 5. Like I said, it's Purdue-like because it's flexible. It is customizable for whatever situation you have. But say we've got a PLC here, really should only be talking to the visualization and the industrial level. So we check those, and if we have a PLC trying to talk to a VPN, we will allow you to see that, and you can decide whether or not that's something you actually want. Probably shouldn't be happening, but we allow you to audit that and see what's there. And you can throw whatever devices, and then in the devices you categorize them, or like I said, for certain protocols, we automatically do that for you. So that's what I wanted to show you in the software, and I'm just trying to be cognizant of time here also. So I'm going to switch back to the presentation and share that again really quickly here and put that back into full screen mode and go to the next one. So what we're really giving you is very consolidated network management for the OT space. This is a tool that is absolutely focused on OT, not IT. That's why when you were in there, you saw HMIs, PLCs, motor starters, remote IO, historians, that sort of a thing. Everything communicating through our switches, not our switches, SDN switches, is visible. So you have an up-to-date network drawing at all times with very easy clickable finding of information if you're trying to debug something. It's the network topology page is very powerful. This is a micro-segmented network. It's just how it's put together. It's not added on. It's not something that you plug in to get. It's just part of how the network is run. And so it's inherent, very robust network security, and it's a very reliable network. These issues that you have with, like I said, loopbacks, VLANs, those sort of things go away when you use an SDN network. It's just a super powerful tool. And so I'm going to leave you with this before we open it up for any more questions. But what would you rather have running your network? That 25-year-old Ford Taurus or something really fancy and new like a Tesla? Although it's funny, I do get some pushback on the whole Tesla thing. Other people have other suggestions for what type of vehicle they would like to see in here. But really, that's the difference. I mean, 25-year-old networking technologies or something brand new and very contemporary.